All right, today we're going to finish up chapter 3 and then start chapter 4. Chapter 3, section 5 deals with absolute values. We're going to do equations and inequalities with those. It's just pretty much formula based. First, what is an absolute value? It looks like this. But what does it do? What does it find for us? Very good. How'd you know that? Yeah, the distance of any number to 0. And distance does not have a sign. For example, if we had Fort Worth over here and Dallas over here, and we were halfway in the middle, let's say it's 12 miles to both from where you are. Since you're going to the left, doesn't make this a negative 12 miles and this a positive. It's just 12 miles. Distance is a positive, is an absolute value. It's a number, and you cannot have a negative. So, for example, the absolute value of 3 is 3 because from 0, 1, 2, 3, it is 3 spaces. The absolute value of negative 3 . 1, 2, 3. It's also 3. But what about this? What's that going to be? No. Order of operations. Absolute values is a special operation. So we find the absolute value of 3, which is 3, and the negative stays up in front. So the answer is negative 3. Likewise with this one. Again, you follow the order of operations. We do the absolute value first. The absolute value of negative 3 is 3 with a negative out in front. In other words, you cannot distribute across absolute values. But let's make it. What is that going to be? Is it going to be 5 or 1? That sounds like a guess. Okay. Remember, it's called an absolute value. This is an equation, so we have to work out the equation first. Do inside the parentheses type thing. So positive 2 minus 3 is negative 1. Once we have a value, a single number, then we can take the absolute value of it. It is 1. Okay, now, before that, what if the variable now is inside the absolute value? what can X be that the absolute value is positive 3? Exactly. We can have absolute value of 3 is 3. Absolute value of negative 3 is 3. So whenever you drop the absolute values, you have to put a plus or minus in front of the answer. So that's our rule with whenever the variable is inside the absolute value equals some number. When you drop the absolute values, you have to put that plus or minus in front of it. So there's that formula. So with that, let's go ahead and now solve equations. To solve absolute value equations, with absolute values, first step, isolate the absolute value. Let's get rid of everything first. That's around the absolute value. Bless you. So what do we have to get rid of first? First, get rid of plus minuses. Anything added or subtracted to the absolute value goes away first. So we have a negative 3. So we add 3 to both sides. Five plus 3 is 8. Then get rid of anything multiplied or divided to the absolute value. This is 2 times absolute value of x, so since it's multiplied, we divide both sides. We isolated the absolute value. Drop the absolute value signs and place a plus or minus in front of the answer. And step 3 is always check your answer. CYA. Because what this means is x has 2 solutions. X can equal negative 4 and x can equal positive 4. That's what that means. Negative 4 in place of x. And this side we put positive 4 in place of x. Remember, our equation was this. Now we just work it out. Order of operations, do absolute value first. So absolute value of -4 is 4. Multiplication first. 2 times 4 is 8. 8 minus 3 is 5. So that's a good answer. -4 is a good answer. On the other side, the absolute value of 4 is 4. 2 times 4 is 8. 8 minus 3 is 5. That works. So they're both good answers. I had one yesterday that again, these parts down here, I'm not going to waste too much time on it because that's stuff we've been doing since day one. You should know how to do that by now. Here's another example. Go ahead and work that one out. What's the first step? Nope. Well, yeah. Isolate. But what do we do first? That's a safe answer. Get rid of the 4 first, since it doesn't have anything to do with absolute value of x. It's added and subtracted to it. So we subtract 4 from both sides. 5 minus 4 is 1. Okay, we have a negative in front here, so we just change the signs. So we have 3 x plus 2 equals -1. Get rid of the 3 by dividing both sides by 3. How many people got that far? Okay, now the next step you would do would be what? Ideally, at this point, since it's isolated, you would drop the absolute value signs and put a plus or minus on this side. But can an absolute value ever equal a negative number? No. So no solution. Because an absolute value can never equal something negative. Let's take another example. This one's going to work, I promise. Yes. Work that one out. First step, isolate the absolute value. Get rid of the -1. So we add 1 to both sides. 4 plus 1 is 5. All right, it's isolated. So when I drop the absolute value sign, I put a plus or minus in front of the answer. So now this means I have two equations. X minus 3 equals negative 5, and x minus 3 equals positive 5. I solve both of those separately. That's what this thing means. One answer is going to be negative 5, one answer is going to be positive 5. So across the board, I add 3. Negative 5 plus 3, 5 is bigger, so the answer is negative. 5 minus 3 is 2. 5 plus 3 is 8. So these are our two potential solutions. So now we check them. We plug them back into the original equation and see if both of these, if we put them in there, if they equal 4. When x equals negative 2 and x equals 8. Negative 2 minus 3 minus 1. 8 minus 3 minus 1 equals 4. So inside the absolute values, we have negative 2 minus 3. They're both negative. 2 plus 3 is 5. The absolute value of negative 5 is positive 5. 5 minus 1 is 4. So that's a good answer. And the other side. 8 minus 3 is 5. Absolute value of 5 is 5. 5 minus 1 is 4. So they're both good answers. Now again, when I say that absolute value of x is equal to 3, again, it's a distance from 0. There is 0. Three is that far away. If I folded my page over, I'd have a mirror image over here. That's also 3. So that's a x is equal to positive or negative 3. Because it's from 0, it's 1, 2, 3, 1, 2, 3. It's the absolute value is a distance. That's going to be important because now the next part we're going to deal with are inequalities. Absolute values with inequalities. That's these guys. And when we graph them, if it has a line underneath it, it's inclusive, so we put a solid dot. If it doesn't, it's an open dot when we graph it. If you don't remember the absolute values, go back to chapter 1 where we talked about it the first time. All right. We know that absolute value of x, when it equals a number, and we drop the absolute value, then it equals a plus or minus of that number. That's given. That's what we just talked about. We have to do the same thing when we deal with inequalities. Let's look at this. Let's look at this formula. So if I say absolute value of x is less than 3, we have an open circle at 3 because it's not an equal sign. What this is, it's talking about how far that number is from 0. So we shade that area down. So it's, if it's less than, it's going from 3 down to 0. We do the same thing with the negative side. It's going from -3 to 0. But remember, it's a mirror image. If I folded the page over, if I folded the page here, these two pictures have to be the same. So if we look at this, remember, these are all our x's. So that's what's going to happen. X is less than a, but it's greater than negative a. So for inequalities, if you have a less than, and you drop the absolute value, it becomes negative a less than x less than a. What if you had this? What if you had that? You have to do piece by piece first. What's the first thing you got to do? Get rid of this, anything outside. Isolate the absolute value first. So we change the signs. So this becomes absolute value of negative x is less than -3. It's less than. So when we drop the absolute value, what happens to it? So since it's less than, whatever's here, that's what we said here. Whatever's here goes here first. And the negative, the opposite sign goes on the other side. So this one goes here. The opposite sign goes over there. Now, because that's a negative, we change everything. So this becomes -3. That becomes greater than positive x. greater than 3. Whenever you change the sign of x in an inequality, as we did in chapter 1, you have to change everything, the signs of the answers as well as the inequality directions. So now what this really means, if we look at this, here's 0, here's -3, here's +3. Okay, they're open circles. -3 is larger than x. So which direction does it go? If -3 is larger than x, from -3, which side do I shade? Let's look at this one. Let's move the x on the other side. -3 is larger than means the same thing as x is less than -3. So it goes this way. And what does this mean? X is greater than 3. So from 3, I say shade that region. So this is an or statement. The answer is x is less than -3 or x is greater than +3. Now, why did we change everything? Because inside the absolute value sign was a -x. And when we dropped the absolute value sign, we had a -x, so we had to change sign of everything. Let's look at that. What's my first step? Very good. Because we have to isolate the absolute value. So we have to divide both sides by 2. Why not? It's not negative. See, with inequalities, we can have negatives because it's not just one number. Now it's a whole span of numbers. So the absolute value is okay. This is positive, so everything's still okay. If we drop the absolute value, since it's less than, that means this A, bring it down, and then the opposite of it goes the other side. So we use that formula. So when we drop the absolute value, this one just brings straight down. And on the other side, it becomes a -5. Now we solve for x. Add 4. -5 plus 4 is -1. 3x. 5 plus 4 is 9. And the last step is get the x by itself. Divide everybody by 3. So our solution -1/3. 9 divided by 3 is 3. So this is what we're saying our solution is. Our answers are between those are our answers. We can use any x between -1/3 and 3. And then what do we do there? Are we sure these are good answers? We have to check our answers. We have to check at -1/3 and 3 in the original equation, see if it gives us a true answer. So we go back to the original. We go back to the original. Let's see if we substitute -1/3 in there. And if we substitute 3 in there. Those are our two endpoints. Three times -1/3 minus 4. Is it less than 10? Three times 3 minus 4. Is it less than 10? So all we did was replace these two numbers in place of x in the original equation. On the left side, the 3's cancel. So we have 2, -1 minus 4. And on the other side, 3 times 3 is 9. -1 minus 4, they're both negative, so we add them. 9 minus 4 is 5. Absolute value of -5 is 5. That's a good sign. Absolute value of 5 is 5. So 2 times 5 is 10. That's a good sign because remember, we can't use them since it's inequality. So we know at the endpoints we can't get to them, but they will be equal to 10. So we check in the middle. What number is between -1/3 and 3? That's easy to use. Even easier. 0. If you can use 0, always use 0. But no, 1 would have worked also. So we use 0. So we have 2, 3 times 0 minus 4 is less than 10. Because if this number is less than 10, we're good to go. 3 times 0 is 0, minus 4 is less than 10. 0 minus 4 is minus 4. Absolute value of negative 4 is 4, positive 4. 2 times 4 is 8. So that works. So those are good answers. Okay, that's less than. That's less than. So whenever you have an absolute value is less than some number, if it's less than, drop the absolute value sign. One side's positive and one side's negative. And there's the formula just to plug it in there. Let's try greater than now. If we had absolute value of x is greater than 3, what would that look like graphically? Remember, it's from 0. So we put an open circle at 3, and x is greater than 3. So it goes this way to positive infinity. If we fold it across 0, then we have a mirror image at negative 3, and it goes away from 0. So if absolute value of x is greater than 3, it goes to the right, which also means that there has to be one going the other direction. So remember, these are your x's. So x is less than negative 3, or x is greater than 3. X is less than negative a, or x is greater than positive a. And there's your formula. Let's see that one. Okay, the absolute value is isolated. So looking at our formula up here, since it's a greater than sign, we're going to have two possibilities. We're going to have whatever's inside the absolute value will go here. So we have 3x plus 2 is less than or equal to negative 1. Or 3x plus 2 is greater than or equal to positive 1. And that's all it tells us is whatever's inside the absolute value sign, on this side, it's going to be negative if it's less than, and then this side, it'll be what it is. Now we just work them out. Subtract 2 across the board. Three x is less than equal to negative 3. 3x is greater than equal to 1 minus 2. 2 is bigger, so it's negative. 2 minus 1 is 1. And divide by 3. X is greater than equal to negative 1/3. That's what it tells us. And graphically, here's negative 1. Here's negative 1/3. It's a solid dot, and it's greater than. It's a solid dot, and it's less than. So that's that. Any questions? You want to do another one, or you're okay? You want to do another one? Okay. Yeah. Okay. First step. Is it isolated? No. So we have to divide both sides by 2. 18 divided by 2 is 9. There's nothing in front. So we use this formula here. If it's a greater than, we use this. So on this side, whatever's inside the absolute value, 2x plus 1 is less than, this is equal to negative 9, because it's the negative of it, or whatever's inside is whatever this is, greater than, equal to positive 9. And work both of those out separately. Subtract 1 across the board. 2x is less than, equal to, they're both negative, so I add them, negative 10. 2x is greater than, equal to, 9 minus 1 is 8. And divide by 2 across the board. X is less than, equal to, negative 5. X is greater than, equal to 4. So those are our answers. Pretty easy, straightforward. It's just mechanical. All right. Let me start chapter 4 now.